composition of the glomerular filtrate. It is protein free, you know that. Actually, legal amount of protein is filtered. It doesn't, actually it's not correct if I say no protein. Legal amount of protein is filtered. There is no cellular elements, white blood cell, red blood cell, platelets are not seen in the filtrate. Concentration of salts and organic molecules such as sodium, potassium, chloride, iron are the same, are similar with the plasma. There are two exceptions for calcium and fatty acid. Pay attention to this, calcium and fatty acids. Oh. Sorry, calcium and fatty acid both are smaller than the size of filtration barrier, but less amount of fatty acid and half of calcium is filtered. Why? Because both are bound to plasma proteins. Got it?
Yes.
Free calcium and free fatty acid are filtered with this, in a way that the concentration of free calcium and free fatty acid is the same. But the total amount is wrong.
So it's always considered equal on both sides.
Regarding calcium and fatty acid. Free calcium and fatty acid.
هم أصغر من
But total
الفتحة
calcium and fatty acid.
هن المفروض يدخلون بس هن اليوم مرتبطات بالبروتين هذا اللي مرتبطات فيه هم راح يدخلون.
أدري مو الناس ما تقول.
Dear students, first session is over.
أنا شرحت.
And 10:30.
Right now it's 10:30.
10:27.
Control GFR is sympathetic nervous system. Sympathetic nervous system. Okay. Pay attention. It's mild and moderate stimulation has no effect on GFR. Okay, why? Because of autoregulation mechanism, intrinsic mechanism inside the kidneys. Got it? But severe stimulation of nervous system actually increases the vasoconstriction in afferent and efferent arteries in both, and it decreases GFR to a great extent. Got it? Autoregulation has actually no role here. Got it? Actually, severe stimulation is seen when there is severe hemorrhage, when there is brain ischemia. Okay, it means it informs body from a danger. In this condition, under this condition, dangerous condition, urine formation is not important. For this reason, GFR decreases and blood is shifted to the other organs. Got it? If I ask you regarding mild and moderate stimulation, it has no effect on GFR. Why? Because of autoregulation, intrinsic mechanism inside the kidneys. No question? Okay. Something else which is worth mentioning, which can control GFR, is some factors such as some hormones such as epinephrine and norepinephrine. Actually, epinephrine and norepinephrine are released from adrenal gland when there is severe stimulation of sympathetic system. Okay, it's actually the effect of epinephrine. And norepinephrine is the same as the effect of sympathetic system. Got it?
Yeah.
The next one is endothelin. Endothelin, actually, it is under normal condition. There is no endothelin. It means it doesn't have any effect on GFR under normal condition. Okay, when there is damage in endothelial cells, these cells secrete endothelin, and there is a vasoconstriction in the actually all vessels of the body. Got it? No question. Something else is angiotensin II. Don't forget, angiotensin II, actually, it is released in this way. In our body, there is a protein in the plasma, which is called angiotensin, tensinogenic, okay? Renin affects on angiotensinogen, and it is converted to angiotensin 1. Angiotensin 1 by ACE, angiotensin converting enzyme, is converted to angiotensin 2. It is a strong vasoconstrictor factor in our body. But the main point is that angiotensin 2 constricts efferent arteriole much more than efferent arterioles. We say angiotensin 2 has more effect, much more effect, vasoconstrictor effect on efferent arteriole. Okay, much more than afferent arteriole. For this reason, angiotensin 2, we say it prevents decrease in GFR. It doesn't increase GFR, it prevents decrease in GFR. Why? Because it is released when there is decrease in blood volume, when there is decrease in blood pressure. Okay? Actually, it wants to keep GFR in a normal range. Got it? Got it?
Yeah.
Don't say it increases GFR. It prevents decreasing GFR. Got it? Okay. Something else is nitric oxide. Nitric oxide. As you can see, it increases renal blood flow, and after that increase PG, and after that increase GFR. It is released from endothelial cell under normal condition. Got it? And something else is, for example, some prostaglandins such as prostaglandin I2, prostaglandin E2. These increase GFR. Why? Because they are vasodilators. Exactly the same as nitric oxide. No question? Was it clear? No question?
No.
Yes, I have. Would you please repeat the role of angiotensin II?
Repeat the role of
Angiotensin
angiotensin II. Do you remember I told you?
It's a very it decreases GFR, but you say something like prevents. It prevents.
Actually, it prevents decreasing GFR. When is it secreted? When is it produced? Angiotensin 2 is produced when the body is not in normal condition. Okay? When there is decreasing blood volume, decreasing blood pressure. Under these conditions, body tries to decrease GFR in order to shift the blood in the other organs of body. Okay, Angiotensin 2 doesn't allow GFR to decrease, but it prevents decreasing GFR. No question?
No. Nitric oxidase increases
Nitric oxide.
RPF, increases it.
Nitric oxide actually increases RBF, increases PG, increases GFR. Okay, the story is the same about PGIT, I2, PG, E2. Yes.
When angiotensin 2 works, like
When
like when we have
Endothelin.
low blood pressure, then macular
which
excitement.
one? Which part?
Angiotensin 2.
Angiotensin 2
Yeah.
when there is decrease in blood volume, decrease in blood pressure.
Yeah, then macular excitement sense there and
Okay, I will show. Okay, no question. Was it clear up to here? Okay. Something else is regarding
Sorry.
auto regulation.
PGI, what does that stand
PGI2,
for?
PGE2.
Prostaglandin.
Both are the same as nitric oxide.
But so, like, what's the full name? I didn't catch it. The full name of them. What does it stand for?
refers for what?
Prostaglandin I2, prostaglandin E2.
Oh,
PG
E2, I2.
stands
Okay.
for
Oh, okay.
prostaglandin E2, prostaglandin I2.
Here's what,
Some prostaglandins are vasoconstrictor, some of them are vasodilators. Okay, these are two of vasodilators. But and kinins, bradykinin are vasodilators. No question? Shall I continue?
both of them with nitric oxide, both of them on vasodilation with nitric oxide?
Yes, the same.
Yeah, it's the same function.
These are actually vasodilator, these are vasoconstrictor. But these are not seen under normal condition.
Only in severe.
Okay, regarding autoregulation, actually, we say the effect of blood pressure, let me write it, it is very important. Actually, I really thank the student who has wiped the board. Who
أحمد
I really thank you. I really appreciate you. Okay. The effect of changing, pay attention please, changing in blood pressure on GFR and RBF is the least or the minimal level, the least, because of auto regulation, as I told you, intrinsic mechanism inside the kidneys. Okay, outside the body, when outside the body, the kidneys are able to show autoregulation. It means it is an intrinsic mechanism. Okay. Actually, autoregulation is done by two mechanisms. First is TGF, tubular glomerular feedback. It means a feedback from tubules toward glomerulus. What did glomerul means? Glomerulus is woman's capsule plus glomerular capillary. Okay. And the second one is a mechanism. It is the topic of today. And the second mechanism is GTB, glomerular tubular balance. It means there is a balance between glomerulus and tubules. Okay, we will study it in reabsorption, not now. reabsorption. Don't forget GETB. We will talk about that tomorrow. Got it? Today we are going to talk about TGF. Okay. Do you remember macula densa?
Yes.
The initial parts of distal tubule, early distal tubule. Actually, it passes from the space between afferent and efferent arterioles. Do you remember?
Yeah.
It means macula densa have actually a specialized cells which secrete something which is unknown subject. Okay, unknown subject toward afferent and efferent arterioles. Okay, TGF is done by JGA. Juxta glomerular apparatus. Juxta glomerular apparatus is formed from macula densa cells. Macula densa cells. Now you are familiar with these cells. Plus juxta glomerular.
Cell.
Juxta glomerular cells.
Cells. JGA.
Juxta glomerular cells. I'm gonna check this. Glomerular
Cells.
cells. That's correct. Okay. Juxta glomerular cells. Okay. As we can see here, macula densa cells are present here, and these are juxta glomerular cells in the walls of both afferent and efferent arterioles. Got it? These cells secrete renin as a hormone, as an autocrine factor. Got it? When this feedback is active. When is it active? Say, suppose that blood pressure is low. Blood pressure is low. When blood pressure is low or blood volume is low, these are two factors which are important in secretion of
Renin?
angiotensin 2, as I told you. Okay? Suppose that blood pressure is low or blood volume is low. What happens? When these factors are low, renal blood flow and renal plasma flow is low. PG is
Decreases.
low. GFR is
Low.
low. Okay. When GFR is low, it means the fluid inside the 2 millions nephron is low. It means the fluid moves slowly along the tubules. TGF is a feedback from tubules toward glomerulus. Got it? It means the fluid flows slowly. In this condition, proximal tubule and thick ascending limb have enough opportunity to reabsorb more water and sodium. Got it? Because GFR is low, blood fluid flows slowly. Thick ascending limb and proximal tubules have enough opportunity to reabsorb excess water and sodium ions. Got it? What happens? When fluid reaches, it means we have a slow fluid flow. Okay. What happens? When fluid reaches macula densa, this fluid, when reaches macula densa, what happens? NaCl concentration is low. delivery of sodium and chloride ion to macula densa is low. Why?
Because
as
it's
I
slow
told
flow.
you, they are reabsorbed in proximal tubule and thick ascending body. Macula densa cells by unknown mechanism actually are sensitive to low concentration of NaCl, a feedback from tubule to glomerulus here. Okay. By one mechanism, they increase efferent arterial resistance. What happens? When efferent arterial resistance increases, what happens?
Pressure
GFR
increases.
PG increases. It has a negative effect on PG and negative effect on GFR because it increases PG and GFR. Am I right?
Yes.
And it actually macula send a message, a signal to juxtaglomerular cells. These cells begin to release renin. Okay? Renin causes angiotensinogen to be converted to angiotensin 2. Okay, you know that. What was the? Let me check it. Afferent arterial resistance decrease. Sorry, I'm so sorry. Afferent arterial resistance decreases. Afferent arterial resistance decreases. Okay? It means afferent arterial begin to dilate. Okay? And angiotensin 2 has effect on efferent arterial resistance. Efferent arterial resistance increase or decrease? Increase. It means efferent arterial resistance increases, afferent arterial resistance decreases. But it has negative effect on PG and on GFR. Kadi, no question?
So NaCl concentration affects the afferent artery.
NaCl concentration in macula densa when it increases,
What?
it actually sends a message
in the hydrostatic pressure.
on afferent arterial, it decreases
The
afferent
resistance.
arterial resistance, and after that, at the same time, it increases renin secretion.
Uh-huh.
You know how angiotensin is produced by renin? Angiotensin 2, as I told you, increases the resistance of efferent arterioles. And both are the negative effect on PG and GFR.
Where-
The feedback from tubules to the glomerulus.
Where does renin come from?
Renin is secreted by juxtaglomerular cells. I told you, JGA has two parts. One is macula densa cells, and the second is juxtaglomerular cell which secrete renin.
When you say negative effect, that means they are increasing.
Yes. PG and GFR increases, also blood pressure decreases. Okay, we have decreasing blood pressure in blood volume and decreasing renal blood. That is.
So they are neither increasing nor decreasing. They are stable.
The condition is not normal. They try to return it toward normalcy, not more than normal condition. But if they try to return it toward normal condition, I told you angiotensin 2 actually prevents decreasing GFR by these mechanisms. Was it clear?
When does this mechanism all occur?
When does this mechanism what is
Yeah.
active? Okay. When blood pressure and blood volume decrease. Okay. sodium, GFR decreases. It means fluid flow is done slowly, is slow. Proximal tubule and thick ascending limb have enough opportunity to reabsorb sodium ions. And after that, actually, sodium reabsorption is followed by chloride reabsorption. Okay? The concentration decreases when fluid reaches macula densa. Macula densa by unknown mechanism is sensitive to NaCl concentration.
What PG meaning again?
PG,
Full name?
hydrostatic pressure. PG is not prostaglandin. Hydrostatic pressure in glomerulus. I have introduced
Yeah, I know. But I want just full name.
PG, hydrostatic pressure in glomerulus.
Okay.
No question? Was it clear up to here?
Excuse me? When the resistance of afferent artery
When the resistance of afferent or efferent?
so the PG decreases or increases.
When the resistance in afferent, in afferent what decrease, what happens? Decrease means vasodilation. PG increases, GFR increases. Afferent, but efferent has biphasic manner, biphasic behavior. No question? Okay, regarding reabsorption. Actually, tubular reabsorption plays a major, much more important role in determination of final urinary excretion rate than secretion. Okay. However, tubular secretion accounts for significant amounts of potassium and hydrogen ions. If I ask you regarding the importance of secretion, don't forget it is very important for secretion of, for excretion of potassium and hydrogen ions plus protein. Okay? But regarding actually, which one when we compare reabsorption and secretion, which one is important? Say quantitatively. Actually, reabsorption is much more important than secretion. Okay. Glucose molecule. Amount filter. If you want to calculate the filtered amount of something, okay, you have to multiply GFR by plasma concentration of that ion, that molecule. Okay? GFR, for example, is per day is 180 liter per day. Concentration of glucose in blood is 1 gram per liter. But it is the filtered amount is 180 liter per day. Got it? All glucose molecules, 100% of glucose is reabsorbed. Okay? It means under normal condition there is no glucose in the urine. In diabetes mellitus, what happens? Glucose concentration is much more than normal. Much more than the ability of transporter to return toward body. Okay, for this reason, glucose appears in the urine. Bicarbonate, as you can see, more than 99.9% is reabsorbed. Actually, not need to memorize the numbers, okay, the values, but it is important that you know body needs bicarbonate for acid-base regulation, because all the time in our body as a result of metabolism we have excess hydrogen. Okay, for this reason we need all bicarbonate ions. Okay, for acid-base regulation. For this reason you can see the reabsorbed amount is high. For sodium, for example, 99.4% is reabsorbed. For potassium, for example, 87% is reabsorbed. For urea, 50% is reabsorbed. Urea is a waste product. Why is it reabsorbed? It is reabsorbed for for helping in
Acid excretion?
in formation of concentrated urine. Okay, it is. Tomorrow we will talk about it. Don't forget this amount. For creatine, actually 0% is reabsorbed. Actually, epithelial cells in the tubules. Let me introduce the epithelial cells. I don't want to talk about glomerulus. Why? Because now we are talking about what is happening here in the tubule study, not in Bowman's capsule. Here just there is filtration. High pressure doesn't allow anything to be reabsorbed. Okay, now we are going to talk about different parts of tubules plus peritubular capillary. Okay, not glomerular capillary. Glomerular capillary is over. Okay, Bowman's capsule is over. Now we are going to talk about these parts. Okay, epithelial cells of all parts of tubule, all parts, are connected together by tight junctions. Sometimes these junctions are not that tight. What does it mean? It means body as small molecules and ions can pass through tight junctions. But in the last portion of nephron, these tight junctions are very tight. They don't allow anything to pass. Got it? But in proximal tubule, no, they are not that tight. This part here is lumen of tubule. This membrane, which is in direct contact with lumen, is called apical membrane. Okay? And this membrane, this one, is called basolateral membrane. Got it? Here is interstitial fluid and here it is peritubular capillary. Got it? The direction of reabsorption is from lumen toward peritubular capillary. Am I right? For example, sometimes reabsorption is done through the membrane of cells. They say this path is called transcellular path. Okay. Sometimes reabsorbed substances cross tight junctions, pass through the spaces between two neighboring cells. This path is called parallel cellular path. But it
Normal or normal?
normal. I told you in some portion of nephrons, such as proximal tubule, these are not that tight. For this reason, whether small solute can pass with ease. But in the last portion of nephron, these are very tight. They don't allow anything to pass. Got it? Okay. On the whole, we have two types of substances which are filtered. One is water, second is solute. Actually, water is reabsorbed by passive mechanism. Which mechanism?
Osmosis.
Okay, passive mechanism, osmosis. Either transcellular or paracellular, no difference. But it both two pass. Actually, water is reabsorbed passively by osmosis process. What solutes? Solute can pass passive. For example, based on simple diffusion rule. Okay, can or simple or facilitated diffusion. Or might be reabsorbed active through transcellular path. Okay? And how about solute reabsorption through paracellular path? Active, passive, or both?
Active.
Through paracellular path.
I think
Passive.
In paracellular path, there is no specialized transporter to transport solutes. Okay, just there is a gap between two cells. Tight junctions are not tight. Got it? Here, if solute is reabsorbed through paracellular path, it is
Passive.
certainly passive. Okay?
Is it the same
Based on
for?
single division, not facilitated division. Here there is no carrier, no protein. Got it?
So in transcellular, passive and active as well?
Both.
Oh,
Both.
okay.
Okay. The water through paracellular or transcellular is reabsorbed by osmosis. It's actually clear. Solute through transcellular might be reabsorbed passively, might be reabsorbed actively. But through paracellular, it is certainly passive. Got it? Okay, thank you. Okay, don't forget. In basolateral membrane of most portions of nephron, most part of nephron, we have sodium, potassium pump. You know that. Primary active transport for sodium and potassium ions. It moves 3 sodium ions into the interstitial fluid and it adds 2 potassium ions inside the cell. Am I right? Yes. If I never sodium potassium pump is seen in apical membrane. Okay? We don't have sodium potassium pump in apical membrane of nephron. Got it? If I told you, for example, sodium potassium pump in apical membrane, blah blah, okay, it's not correct. It's wrong. All the time. If there is sodium potassium pump, it is seen in basolateral membrane. Okay. What's the function of sodium potassium pump? Actually, it removes sodium ions from the inside the cell. Am I right?
Yes.
What happens? There is concentration of sodium inside the cell.
Goes down.
Yes, goes down, decreases. And it is electrogenic pump. Am I right?
Yes.
Sodium potassium pump is electrogenic. Do you know what's the concept of being electrogenic?
It works based on the voltage difference between inside the cell and outside the cell.
Actually.
It needs ATP. This one needs ATP,
Do you
right?
have any extra explanation?
It tries to keep the electrical difference neutral. So, which for every for every sodium it takes out, it pulls in 1 potassium, so that the electrical difference remains the same.
Why there is one negative charge after one time working?
I
Sodium
think
is +1 and potassium is +2.
Because potassium has anions.
Okay, 3 positive ions are leaving the cell. Instead,
7%.
It's
It's responsible for 7%.
So that potassium will later, through facilitate diffusion, will leave so that it can pump, use it in the exchange again.
Doesn't potassium has anion or no?
Let me talk about that. Inside the cell is negative. Why? Because of accumulation of phosphate and proteins, which cannot leave the cell. Am I right?
Yes.
Now suppose that when there is positive ions, okay, these ions begin to neutralize negative charges. Okay. Now suppose that we have one sodium potassium pump is here. Pay attention, please. 3 sodium ions go outside. Okay, it means 3 negative ions are added to the membrane because now they are not neutralized. Got it? Instead of sodium, it adds 2 potassium ions. 2 negative charges are neutralized now, but after one time working on pump, what happens? As if one negative charge is added to the membrane. Got it?
Yes.
For this reason, they say pump is electrochemical. Was it clear?
Could you repeat it?
Was it clear? Not your turn. Don't mess it up. If you have any questions, don't hesitate to ask. No questions?
Jafar wants
Could you repeat it? This part when it enters?
Again, let me show it again. You know, resting membrane potential is negative.
Yes.
Okay. Inside the cell, there are a lot of negative and positive ions which neutralize each other. Okay. Negative ions which are not neutralized are immediately under the membrane. Got it? Suppose that one sodium potassium pump is here. It begins to actually transport 3 positive ions outward. Okay, what happens? We have 3 negative ions, 3 excess negative ions. These negative ions, these 3 ions, okay, begins to add to the membrane. Okay, these 3 negative ions. Got it? Was it clear up to here? Now, sodium potassium pump brings 2 positive ions, 2 potassium ions inside the cell. They begin to neutralize 2 of these negative charges. After one time working, 1 negative charge is added to the membrane. Am I right?
Yes.
Suppose that all the time pump is working. It means a lot of negative charges are added to the membrane. Here, when this pump begins to work, sodium concentration decreases in one side, in the other side, negative ions inside the cell increases. Negativity increases. Both ions decrease in sodium concentration plus increase in negativity causes sodium ions to come inside. Got it? Sodium ions like to move inside because there is lower concentration of sodium here and increase in negativity based on electrochemical properties. Was it clear?
Yes.
In the apical membrane of proximal tubule, just proximal tubule, we have a carrier, we have a transporter here, which transports sodium ions, okay, with something else. For example, with glucose molecule. When sodium and glucose molecule attach to this protein, they begin to move inward. What happens? This carrier is called sodium glucose transporter, SGLT. We have 2 SGLT2, 90% of SGLT in the kidney is SGLT2. In the intestine, SGLT1 is dominant. Got it? It is SGLT. When I see SGLT, it is
Sodium glucose.
simple diffusion, facilitated diffusion,
Facilitated.
primary active transport, or secondary active transport.
I think facilitated diffusion.
Secondary active transport. Facilitated diffusion is a carrier in the membrane which transmits just glucose or just amino acid based on electrochemical gradient. Actually, for glucose, we don't have electrical gradient because it is a molecule, not an ion. Okay, based on chemical gradient. It is facilitated diffusion, not here. It is secondary active transport. Do you remember this is secondary active transport is as a result of sodium accumulation outside the cell. This sodium accumulation is a source of energy because sodium all the time likes to move inside the cell. Got it? It is secondary active transport. Secondary active transport means moving against electrochemical gradient. Here, sodium is moving based on electrochemical gradient. Secondary active transport for what? Glucose. Glucose here is moving from lower concentration to higher concentration. Here is lumen. It is not plasma. In plasma, glucose concentration is greater outside the cell. But here in lumen, it is less. In the lumen, glucose concentration is less than inside the cell. Got it? Was it clear? For this is the SGLT just is seen in the intestine and kidneys, the absorptive surfaces. Got it? Thank you. After entering the cell, glucose is removed based on against electrochemical gradient by sodium potassium pump. Glucose is removed by glucose transporter. GLT. GLT is one mechanism. Simple diffusion, facilitated diffusion, primary active transport.
Facilitated
diffusion. It is facilitated diffusion. Because one molecule is moving by a transport, a carrier. Was it clear?
It was
Last question.
glued or GLT.
GLT. SGLT is secondary active sodium glucose transporter. Glucose transporter GLT is facilitated diffusion of glucose.
It was glued.
GLT or GLT?
Yes, glute. Glute 1 to 7. We have 7 types of it. Yes, thank you. But the glute SGLT. No question. This mechanism is seen just in proximal tubule. What does it mean? It means when excess glucose cannot be reabsorbed in the proximal tubule, it cannot be reabsorbed in the other parts of tubules. It appears inside the urine. Got it? I have sorted. I don't know why. No question. Sometimes we have the sodium likes to move inside all the time. Okay, sometimes we have one site for sodium here and one site for something else inside the cell. For example, hydrogen is a secretory mechanism. Sodium comes inside, hydrogen goes outside.
Exchanger.
This exchanger, it is a exchanger. It is a type of secondary active transport. This exchanger is seen in proximal tubule and some parts of nephron. Ready? Do we have secretion in proximal tubule? Yes. Okay. Sometimes sodium comes inside and it brings amino acid with itself. This mechanism is seen just in proximal tubule. What does it mean? It means if there is no carrier here, there is, for example, or there is a lot of amino acids, okay? these mechanisms are saturated and amino acids begin to appear inside the urine. Was it clear? 100% of glucose molecules and amino acids are reabsorbed in proximal tubule. Got it? Okay. Now I think you can understand the mechanism. Okay, here you can see sodium handling in the nephron. Actually 65. Here it is